Well, we're here with Andrew Palfreyman, and we're talking about the Woodward effect, the MLT drive, Mach's principle, and the STAFE 2006 conference. Well, Andrew, I guess I should start out by asking about your presentation materials, right? You're doing a presentation this year, so...
Well, I didn't present. I was the supporting co-author.
Oh, well, I think that qualifies, though, because you've been part of the team that was doing the presentation.
Yeah, and it's the first time I've ever participated in anything like that, so I'm no longer a virgin in whatever name we can give to that particular activity, but it was very nice.
Sure.
I'd love to do it again.
You know, I was kind of surprised, actually, that the conference has had its drier moments, you know, like a couple of yesterday, but the Woodward effect stuff, not only was it compelling, I mean, tons of photos, tons of information, you know, readouts on the thrust and power and stuff, but it dovetailed together. You had these experiments, one after another, with a follow-up by Tony Robertson, and it fit together. It was like putting the pieces of a puzzle together for something larger.
Yeah, let's just cut to the chase, Tim, because you know all this talk is getting to try me to utter the magic phrase 60 kilograms, isn't it?
Yeah. Well, that's the prediction, right? For your next...
No, yes. Well, actually, the prediction is much higher than that, but I wouldn't dare say that in print. But I can say it to the camera because.
Well, and again, using a different mathematical.
Because I'm drinking this beer, you see, and it's okay.
Well, and using a different model than the one you're using, different math. Tony Robertson arrived, very different hypothesis, at 100 kilograms, or not 100 kilograms, sorry, 100 newtons. So.
Yeah.
It's about 25 pounds. So you're talking about scalability.
The big picture is that, yes, the Woodward effect has some built-in scalability, which the equations say with our current technology, nothing exotic, we should be able to generate metric tons of thrust with a Woodward-style device. That's the bottom line. We should be able to generate metric tons, Saturn J1 plus levels of thrust with current technology. We should be able to do this. There are many barriers, one of which is heat, and clearly when you build something big and powerful, you have to watch out for heat dissipation. The nice thing about the Woodward effect is that the more efficient you make your devices, the more bang you get for the buck, which I guess applies to most devices, but particularly in the case of a Woodward device. If you're able to engineer devices with very high Q factors, which is an engineering term for an amplification factor. I'll briefly explain that. Is that all right?
Oh, absolutely.
Okay,
absolutely.
Well, the Q factor is really simple. It's not an example of getting something for nothing. When you're working with reactive power, which is essentially power that gets returned to the source in the same cycle, the kind of power that you put on an ideal capacitor, you put in voltage and current and it comes back to you in the other half cycle. No real power is dissipated. That's an ideal capacitor. Whereas a resistor takes all the power you give it and pumps it out as heat. That's real power. Now, the equations that we use and the configuration that works with the Woodward effect is all reactive power, which means that theoretically you can build a Woodward device which consumes no power and generates tons of thrust, which of course raises some interesting questions on conservation of energy and momentum.
One of the big ones has been the wormhole territory, which is kind of a nebulously defined term, and I think a lot of people, myself included, when I heard about this, I thought, you know, this is a mathematical artifact, but as it turns out, you guys are talking about a real negative mass, and I'm almost wondering if this could be used to stabilize the throat of a wormhole at some point.
Yeah, nobody knows. We don't know. We have no clue what it means. All we know is that the equations are very simple. They say there's a mass fluctuation. It has a number associated to it. Simple example, you have a mass of an object which you manipulate in a Woodward apparatus, and it weighs 10 grams. And you generate a mass fluctuation of increasing quantity, which goes plus minus. So you start off with this nominal 10 gram thing, and you go plus a gram, minus a gram. So when it's heaviest in half a cycle, it's weighing 11 grams. And you weigh it at the lightest, it's 9 grams. And as you increase that delta m, that change in the mass, you'll get to plus 15 for a 5 delta m, and 10 minus 5 is 5. And eventually, your delta m, your change in mass, will be equal to the rest mass of the object. So with a 10 gram object and a change in mass of 10, you'll get plus 20 and 0. And you push it even further and you'll get plus 30 and minus 10, whatever that means.
Yeah. Well, one of the things that had occurred to me, I could be way off base here, but a lot of the approaches to generating negative energy, right, again for stabilizing a wormhole throat, you know, which could be useful within this century for a micro wormhole. You know, they don't require as much energy as the large ones. The thought that had occurred was a lot of the physics community has been looking at that in terms of a field generation. They're looking at using particles to create it from energy. And you guys are working on the other side of this equivalency equation. So instead of generating, you know, I mean, in terms of reactor power, right, you're going to be sucking juice out of this thing like crazy. But in your case, you're doing it from the mass level. So you're using well-known technologies, but you're still coming out with negative mass. But with E equals mc squared, you know, a few pounds of negative mass is billions and billions of watts of negative energy.
Yeah, let me just point out that the mass fluctuation, according to the theory, occurs in mundane devices throughout the world, inside cell phones, inside radio transmitters for high-power radio stations, inside research facility accelerators, and so forth. In other words, all around the world, every hour, every second of every day, we are seeing mass fluctuations, according to the theory, inside mundane devices of quite staggering magnitude. Now, it occurs to me that if we are seeing mass fluctuations like that there must be a whole slew of things right now which are trying to go negative, and in my opinion clearly they're not, otherwise the world would look rather different. So therefore Paul March and I have talked about this at length, and Jim too, Jim Woodward. I think I lead the pack here, but I think Paul's not far behind. He may even be ahead of me on this in terms of how aggressively you state it, but my predilection is to say that it's an asymptotic thing. That is to say that you don't go negative. That is to say that you asymptotically approach zero and never get there. And so, I'm not of the opinion that a Woodward device can generate a negative mass. However, the equations start to blow up when you approach very small mass numbers, because one of the key factors in the equations is the density, the proper density, mass density of it. Now, when you reduce the mass of something and keep its volume the same, its density gets less. So you get more and more like styrofoam and less like metal. So, in those regimes where you would have expected it to go negative, but in fact it's bottoming out asymptotically, I would expect the equations to anyway go weird, and perhaps odd things happen just because we're outside the linear regime of the equations. All our assumptions, the predictions of big thrusts, the predictions of any thrust at any level, are based on this very simple model of the impulse term only and not the wormhole term. And as soon as you get into these low density regimes, the equations go very nonlinear. Solution is probably a Green's function. Several people have stepped up to the plate verbally and said, yes, I'll try and solve this for you, but nobody has actually taken the Woodward, and if you're out there, I would like you to have a shot at this, because I haven't had time, and nobody I know has had time yet. We need to get a closed form solution, or at least a shot at perhaps a fastly converging iterative solution to the Woodward equation at low densities. That is to say, in the high drive regime. Now, you don't have to go very far to get to the high drive regime. Paul's already there at 2 megahertz. God help me, I'm there at 100 megahertz with my little capacitors, which are over there in my briefcase. And I haven't built it yet for various reasons, but that promises to have a mass fluctuation ratio based on this simple calculation of thousands of %, which is a ridiculous thing. And that means that, you know, a 1 gram object would have a mass fluctuation in the kilogram or megagram. I mean, so clearly something else happens. Otherwise, one would observe this in radio stations and in cell phones and what have you.
Sure. So in the classical sense, at least, because technically I don't know if you'd call this anti-gravity, but in terms of what the public would visualize, you know, the flying cars, the Jetsons and stuff like that, this could lead directly towards stuff like that.
Right. Well, it's a complete paradigm shift. It's a total paradigm shift. It's a bigger paradigm shift than the invention of the wheel. First of all, Joni Mitchell's dream of paving paradise and putting up a parking lot would be totally reversed. We could rip up all the asphalt on the planet. We wouldn't need it anymore. Turn the planet back into a green park, and there will be no need for anything except for walking paths through the beauty of it. All the dirty, nasty, smelly industry could be put into low Earth orbit at little to no cost, and made to, legislated to be up there, so there's no dirty stuff hanging around here on the planet. The planet could be for us, and be a beautiful environment, and all the nasty stuff could be maybe, as per Ed Botello's vision, on some devastated version of the future moon, or in low Earth orbit, or somewhere like that. But essentially, you get all the nasty stuff out of the way, and you keep the planet nice for you. Architecture, you build woodward devices into structural members. You can create arches 50 miles long and 5 miles high, and make buildings that you wouldn't believe, something out of the cover of a science fiction book, because you have self-supporting members throughout the building, which have basically the ability to support their own weight and 10 times their own weight at a thickness that you couldn't believe before. And this goes way beyond carbon fiber, nanotube constructions and the like, or nanomaterial capabilities, way beyond nanomaterial.
Oh yeah, because you could use things that otherwise wouldn't even be supporting members, but
Correct.
by reducing the mass in some ways.
You have built-in thrust essentially in every brick, if you want to think of it that way.
Yeah.
Like if the power turned off.
Well, yes.
Yeah.
Until the power turns off.
Yeah, actually that's I've read about that in science fiction novels. I believe there was one, it might have been Arthur C. Clarke's 3001, where, or actually no, it wasn't. It was, I believe it was the Gentle Giants of Ganymede series by James B. Hogan, and he talks about an enormous arch on an alien planet facing the planet. The arch is 20 miles high, and so you have a spectacular view standing upside down on it in a gravity field. So that might be a little bit more advanced, but it's along the same lines of paradigm change, I think.
Indeed, and of course interstellar flight, Trans-Galactic Flight. Basically, if you have constant thrust, you can accelerate forever and get up to humongous fractions of the speed of light and keep going. And you can do it without propellant. You have to carry your own propellant with you, so off you go. Basically it opens up the near interstellar space.
Sure.
The few light years around us, and.
Well, I guess I should touch on the experimental part of this for a second in terms of replications, because right now it looks like Woodward has done replication or experiment number 1, and he had a very marginal thrust out, but it was enough to demonstrate for most people that something was going on. And then Paul March followed up, and March has a lot more thrust, much larger levels. And now you're predicting that at least the potential theoretical capability for 60 kilos, although it may not reach that, and if it doesn't, it's still a work in progress. But this means that if people out there who are interested in building these things, if they have the tenacity and the stick-to-itiveness to build it correctly, because it is technically challenging, they could see some real results with not a lot of money and not a lot of complexity.
That's the reason I got into this thing in the first place, is that it's a tabletop experiment that even a klutz like me could have a shot at, and I was bottom of my class in woodwork at school.
Sure.
I highly recommend this as an experiment to anybody. You need one coil and one capacitor, and since we don't really know what works, which is part of what this conference has been about, a large amount of creativity in the selection of components, in even a stochastic, maybe even a partially educated way, and scientific wild-ass guesses, swags as to what you should stick in there and try and make it work, is pretty much as good as anything else. I'm not trying to say that we're out of control here. I'm saying that there's a lot we don't know, and that somebody might come along and just hit upon the right thing first time out of pure luck, and that would be a beautiful thing. Absolutely.
Well, now, do you have any, I guess just kind of an educated guess about as testing continues over the next year, until maybe STAFE 2007, in terms of papers with experimental results that might be coming back, what would you guess as far as output thrust?
Well, I'm hoping to get my 100 megahertz device constructed in the next 12 months. Paul is pushing on up to 10 megahertz. Jim is staying down, I think, around the 50 to 100 kilohertz regime, but he's tightening up all his protocols. Tom Mahood, Jim's grad student, is thinking of putting together a torsion system, which will be another way, which was actually resurrected from previous experiments as a way to have an independent verification of the effect, since we're seeing some question marks from Austria now, and we need to get our acting gear in terms of covering the bases and saying, look, we measure it this way, we measure it this way, we're pretty sure we've got what we say we have.
Oh, absolutely.
And that's very important. And a torsion balance is exactly how their balance works. So I think it behooves us actually to try and get as close to them as they have tried to get close to us, to try and see why we disagree on the data. They saw pretty much of nothing or hardly anything in their data. It's very questionable. Now there may be some big oops that they've overlooked that we haven't. I'll say we because we are collaborating essentially. We're trying to do this together. It's not a confrontational situation. Thank goodness. I'm very grateful that Martin and Jim have been able to act
they in fact,
in a professional fashion.
He in fact, Martin Timar, he apologized after presenting a negative result, and his apology was we had hoped to be able to build it in a manner so that it would support what they're doing.
Indeed.
But they unfortunately they weren't. And in fact, from watching their presentation, the thing that immediately struck me as being primarily different was they had a very large Faraday shield, which is really kind of like a large aluminum cooking pot, and it has sidewalls that are probably half an inch thick on it.
Yeah.
You know, and I've done lens levitation work. I've worked in that environment, and
you mentioned this.
It's going to set up a magnetic field. And
there are so many parameters, Tim. There are so many unknowns in this thing that it's very hard to make a hard and fast judgment as to whether this particular construction will work, which is back to what I would encourage people to experiment wildly with different configurations. And by the way, a capacitor and a coil is not the only way to build this sucker. It may be the easiest for some people, but those people who have access to other ideas, there are many ways to skin this cat. It doesn't have to be a capacitor. We're looking for a change in energy density over time and a way to affect it. Our current flavor du jour is the Lorentz force, but there, it used to be a piezo pumping, but that didn't work, it turned out, because the phase velocity of sound is very different to the phase velocity of light, and so you cannot maintain a stable phase relationship between a mechanical push and an energy density change at the speed of light at the same time.
Well, it's important, I think, that we kind of focus on that for a sec, because the Mach's principle is often associated with the hundreds of off-center rotator experiments, and as well as a few piezo experiments, in the anti-gravity community over the last 30 years.
Well, Lathwaite comes to mind. Professor Lathwaite of London comes to mind when you say that.
But, if it turns out that the phase angle and the speed of light relationship to the mechanical propagation speeds, right, because all of your mechanical propagation speeds are really acoustic in manner of speaking, then that could explain why this theory has stood there. I mean, Einstein himself loved Mach's principle. Apparently he supported it. Ernest Mach felt like he had a very strong foundation. But at the same time, when you get into the experimental part of it, they've had such a long run of failure with this idea that I'm sure a lot of people out there who are familiar with it might question, what is it that makes this different? And in this case, it's the phase angle. That's what it sounds like. Oh,
very critical. And maintaining a stable phase angle. One thing we would like to get funding for would be, because I don't think this would be cheap, will be a self-regulating piece of apparatus that allows us to nail that phase angle. Right now, because of temperature changes, it's almost impossible to maintain a stable phase angle, even in a resonance circuit. When you have when you have two independent phases, it's even harder. So we would like to nail that phase. We'd like to nail the temperature. We'd basically like to have the whole thing auto-regulated, but that costs bucks. And we're all on the shoestring.
Sure,
all of us.
Sure.
It's all backroom stuff.
Well, and hopefully though, I mean, actually that was one of the notables. And hopefully the funding will show up. But as I understand it, I believe Paul Murad, the Section F conference chair, he had mentioned that you guys have been investing. You've been bankrolling this yourselves. It's this passion that you have, this dream that you believe in.
Oh, thousands of dollars of my money, thousands of dollars of Paul March's money. God knows how much money Jim has spent. Of course, it's not his money, but a lot of it is his own money too, by the way.
Yeah,
that's not often mentioned. But believe me, a lot of it's come out of Jim Woodward's own pocket. It isn't all Cal State Fullerton and grants.
Sure. Well, I think part of it is, people might argue this is their passion, this is their hobby.
It's my hobby. Just let them do it. Yeah.
Yeah, but at the same time, I would counter argue to that where, in a way, given the expertise, given the promising results, I think it's obviously time to begin stepping things up. It's time to take it to the next level, and the way to do that is to give the people with the expertise the resources to do it.
Yes, but you and I are not squarehead bureaucrats. If you're out there listening, you have to change your mind about how you operate.
Yeah, well, and hopefully over time, hopefully that this will start to make an impact. I would suspect...
The risk-reward ratio is unavoidably amazing.
Well, and we did have, one of the things I should note, we had military officers in the audience this year. We had NASA personnel in the audience this year. So these are the organizations that could help. But at the same time, I think that the Robert Bigelow-style investor can also be of more assistance because they can allocate funding to these things and pick up that passion in the same way that you guys already have it.
Right. Once we get out of the noise and once we start showing consistent, my opinion would be gram level and above thrusts, which are unambiguous, you start to be able to get into a position where you can put this sucker on a wheel, or several of these things on a wheel, and keep that wheel turning by dint of the thrust. Now, once you've overcome the stiction of the axle, you can actually accelerate your wheel, and once you've done that, you can remove the power feed through the commutator and let it power itself. And that's where it starts to get very interesting.
Now, you'd mentioned this because it sounds like there's almost this angst about the over-unity implications. And it is, I guess it is troubling in many ways for some people.
Well, I don't have any angst about it because Mother Nature is Mother Nature and you have to follow the data. That's the bottom line. So I don't have any preconceptions. I'm not going to sit here and say, yes, the Woodward device is an over-united device, because I don't know that. I can see scenarios where you can argue that. I can see scenarios where you can gainsay that. And I would say that it probably is not, because it's probably a device where local momentum is conserved. There is some disagreement about it. It's possible that one might be able to steal a little bit of momentum and pay it back tomorrow. After all, the theory relies upon Wheeler-Feynman advanced radiation from the distant mass of the universe, the so-called far-off active mass, or foam.
So in a sense, you're already doing that to some degree.
And in a sense, that's built in. So in a sense, Tom Mahood actually had a sign-up on Woodward's lab, I don't know if it's still there, with the motto, tomorrow's momentum today. And that's a fairly good description of how the device operates.
It continues to just amaze me to no end how a device that in some ways is so simplistic, I mean, it originated really from, again, these mechanical designs. It was very Newtonian in some ways, kind of from where it originated from, has become something that would have such deep implications for, like, maybe even cosmology. Because, in a sense, the distant far-off mass, this gets back into the really big questions really rapidly.
Yes, there's a beautiful irony in all this, that Jim Woodward is an emeritus professor of history. And I have to admit, I cracked up when I read his paper called Killing Time, which is on his website. It's been there for several years, where he talks about the fact that the philosophical implications of a Woodward device on time are that the future is actually cast in stone. Now, I'm not going to comment on whether I believe that or not, but he makes a very good argument that if that's the way it works, as described with the advanced ways to the future, stealing momentum from the future, that the device essentially takes energy from the future and uses it today, which means we're robbing our great-grandchildren of many gigaergs, gigajoules. There's a larger philosophical implication to this, and it's all about time and determinism and free will and all those great, good, beautiful unknowns that we've been pondering for generations.
Yeah,
so there is a springboard to that. Yes,
the fast track to philosophy.
Absolutely. Yes.
So again, amazing. And on behalf of my audience, I think I'd like to thank you all for being able to contribute so much in terms of sharing information and resources with us. Because I think that's one of the other wonderful parts about it, is that you guys have been really open to the open source community and replication efforts, whereas a lot of other, like, theoretical physicists, for example, are really more focused on doing their own work without much, I guess, interest in sharing it until it's finalized.
It's a peculiar thing. I bounce this off my friends, my close friends, people I've known for 10 years. Most of them are techies. Most of them have physics degrees, so I don't know why it is. Most of them are engineers. because I'm an engineer with a physics degree too. Some of them are British, some of them are Canadian, some of them are American, and some of them are European. And you know, they say, "Oh yes, I'll go off and read this. I'll go off and read this," and it's really funny that, you know, they don't get fired up. I don't know why I'm fired up about it and they're not. I don't understand that.
Well, that's the bug, though. That it's and everybody has their own, but it seems like in this community and breakthrough propulsion in general, and you know, even with the aerospace community, I've met aerospace engineers who they see it for the first time, they get really excited, and others see it for the first time, and it just doesn't spark.
I think people get to them. I think there's a conspiracy.
Yeah. Well, you know, I'm not sure about that. I wonder if it's just social conditioning. You know, unfortunately, but I think that's one of the things that we're starting to change. You know, by helping them realize there's a greater reality to it than we would imagine, I guess.
Well, there is anyway.
Yeah. Well, thanks again for your time, Andrew, and again, thank you for this wonderful presentation, and we look forward to hearing more about your work in the future.
Take care.